500 million years ago, Earth looked almost unrecognizable. The continents were empty. No trees, no soil, not even a blade of grass.
And yet, beneath the waves, something extraordinary was unfolding. In a geological blink, life had exploded into astonishing new forms.
Creatures with eyes appeared for the first time. So did jaws, claws, and armor. Scientists call it one of the strangest bursts of innovation in the history of life.
One creature, larger than anything before it, already ruled these seas. Its name, Anomalocaris, and its rise marks the beginning of a very different world. This is the Cambrian Period, roughly 541 to 485 million years ago. Earth's land masses were scattered differently than today, fragments of ancient continents drifting across a warm, shallow ocean world. There was no ozone layer thick enough to block ultraviolet radiation, so life stayed almost entirely in the water. Oxygen levels were lower than today, but rising. Warm, sunlit seas stretched across much of the planet, rich with minerals washed in from barren continents. It was the fossil beds like the Burgess Shale in Canada and the Chengjiang deposits in China preserve this world in extraordinary detail. Soft tissues, gut contents, even eyes were fossilized in fine sediment. A rare window into Cambrian life. Trilobites were among the most successful animals of this world. Armored, segmented, and equipped with some of the earliest complex eyes ever to evolve. Vision changed everything. Once an animal could see, it could hunt with precision. And once it could be hunted, it needed defenses. This is likely why so many Cambrian animals suddenly developed hard shells, spines, and armor plating. Predators like Anomalocaris used flexible, spiny appendages to seize prey, along with a circular, plated mouth. Growing up, smaller, stranger creatures shared these waters. Opabinia had 5 eyes and a long, flexible proboscis. Hallucigenia walked on rows of spiked legs, an anatomy so unusual that scientists originally reconstructed it upside down. Swimming among them was Pikaia, a small animal with a simple rod of cartilage running down its back, a primitive notochord, linking animal alive today.
Beneath these swimming predators, sponges filtered nutrients from the water, and early reef-building organisms began forming some of the first complex habitats on Earth.
For over a century, this rapid burst of new life puzzled scientists. Charles Darwin himself worried it threatened his theory of gradual evolution. If evolution worked slowly, where were the ancestors? Older fossil sites in China, Namibia, and elsewhere offered an answer of a kind. Simpler, soft-bodied organisms stretch back tens of millions of years before the Cambrian, evidence that evolution had been building toward this moment for a long time. Several factors likely converged. Rising oxygen allowed larger, more active animals to survive. Ancient genetic toolkits, genes controlling body plan and development, may have reached a threshold that allowed rapid experimentation in shape and form. And the rise of active predators likely triggered an evolutionary arms race, pushing prey to evolve defenses and predators to evolve new ways past them. One of the most revealing moments in Cambrian science didn't come from finding a new animal. It came from a mistake. For decades, different parts of Anomalocaris were classified as separate species. Its appendages were mistaken for shrimp-like animals. Its mouth was classified as a jellyfish. It wasn't until the 1980s, when researchers examined more complete Burgess Shale specimens, that they realized these pieces belonged to one much larger predator. The discovery reshaped how scientists understood the Cambrian food web. Anomalocaris wasn't just another strange invertebrate, it was the apex predator of its world. Its existence helps explain why so many smaller animals needed armor, spines, and eyes in the first place. Pikaia's tiny notochord remains one of the most important pieces of the puzzle, a reminder that some of the most ordinary-looking Cambrian animals turned out to matter the most. By the end of the Cambrian, nearly every major animal body plan seen on Earth today had already appeared in some early form. Later periods would refine these blueprints, but the basic architecture of animal life was largely set in place during this one extraordinary stretch of time. Much about this world remains uncertain. Scientists still debate how fast the explosion truly was, and how many species remain buried in ancient rock. But the broad outline is clear. Evolution moved faster and more experimentally here than at almost any other point in its history. The barren continents of that world would eventually turn green, but the basic body plans forged in these ancient seas, every backbone that bends, back to that ancient restless ocean, fragments of a world that disappeared.